Okay, so last week when we were talking about scalars and vectors, we got into two terms, two measurements that we use in physics, distance and displacement. We're going to take those a little further. We're now working in the realm of distance and scalars, and we're moving on to speed. Okay, so speed, you should be familiar, especially those of you that drive. You have certain speeds you're supposed to travel at. All right, let's talk about what speed is. Speed, which is represented with the letter v, because we've already used s for distance, is the distance you go per unit of time. All right, so you have distance divided by time. So you will also see that, let's make this a little smaller so you can see everything. Our distance and our time is scalar, so that means speed is scalar. Just a little side note, you do want to know this. SI units for speed are always in meters per second. If I give you a problem that isn't in those units to begin with, I will make it clear if you have to do conversions. So typically if it's given to you in other units, you won't have to do the conversion unless it says, give your answer in meters per second. But on like a standardized test, you want to know that. Okay, so next part. You will need to be able to rearrange equations in this class. The same rules that apply to numbers and fractions apply to variables. Okay, so starting with the easy rearrangement, we want to solve for s by itself, which means we need to isolate this s, which means we have to get rid of the t. If we're dividing by t in the equation, to move it to the other side, you have to do the opposite, because you want t over t, anything divided by itself is equal to 1. And then anything multiplied by 1 is the same thing. Okay, so whatever you do to one side, you must do to the other side. So these guys are going to cancel out. That's just left with 1, and s times 1 is s. So s is equal to our speed times our time. So your distance, or your position, is equal to your speed times multiplied by the time it takes to go that distance. Okay? Now, trickier one is solving for t. Okay? Initially, most of you, your gut reaction is going to be to divide by s and you're done. But that's not true, because this equation actually means v is equal to s times 1 over t. So if you divide by s, you're going to have 1 over t equals something, not t equals something. So if you ever have a variable in the denominator, so being divided by it, your first step is to get it out of there. So we actually start this rearrangement the exact same way. We multiply by t, so we'll have distance, or speed times time, is equal to distance. And then, now we have just plain old t instead of 1 over t, so we divide by our velocity. Okay? So time is equal to your position divided by your speed. See, even I kind of get my letters mixed up. The difference between velocity and speed will make more sense when we get into that equation. But plain old v is technically speed. So, there's that version of. I want to teach you LeSU, and you will be required to do this on all homework classwork assignments if you want to get credit. There will be times when I explicitly tell you you have to show your work in LeSU on a quiz or a test. Okay? And while it's going to seem really tedious and easy for an equation like this, when we get into more complicated equations, it will make a lot of sense. All right? And this is the key thing to do to avoid stupid mistakes. We all make them. So what you want to do is try avoiding them. I make them too, especially if I don't do LeSU. This significantly reduces the chance that you will make a silly mistake. All right? We're going to start using it with a really easy equation, because that way you can learn the LeSU, get familiar with it, and then when we get into more complicated equations, it'll just be second nature. Okay? So let's apply this to a problem. So we have this problem, and then I'm going to cross off a typo here. Unfortunately, this typo will keep showing up throughout. But the slowest animal ever recorded or discovered is the red sea crab. It travels at an average of 5.7 kilometers per year. And we want to know how long it would take this crab to travel 100 kilometers. Excuse my typos in here. So first thing is listing what you know. In the problems, if it's a test or quiz that you can write on, go through, underline your numbers, and then you need to figure out what those numbers stand for. Right, so reading, we see that this explicitly tells us that's our average speed. So we know V is 5.7 kilometers. All right, and then we have how long would it take this crab to travel 100 kilometers. All right, so if it doesn't explicitly tell you, you kind of got to look at your units. Kilometers are measured distance. Okay, so we know S is equal to 100 kilometers. And you can also tell just based on the question is how long would it take? That's asking you about time. Okay, knowns listed out are 5.7 kilometers per year is our speed, distance is 100 kilometers, and time is our equation. So next thing you got to do is write and rearrange your equation. So what equation did we just learn? That's the one we're going to be using. And then solving for time, you can memorize this or you can just remember how to always do it, but time is equal to your distance divided by your velocity, or your speed. I keep messing that up, I'm sorry. So there's our equation and our equation rearranged. If you're using the equation as is, then all you have to do is write that down. Next thing is substitute your known information. You don't do any math yet, you just literally plug in the numbers. Okay, so we take our speed and plug that in for our speed, and take our distance and plug that in for us, and literally just rewrite that. Okay, so here we have 100 kilometers plugged in for our distance and 5.7 kilometers per year plugged in for our speed. Next, the second S is when you actually do the math. And you take your 100 and you divide by your 5.7. Okay? So that's 17.5. And then last thing is writing your units. Now, if you substitute with your units like I did here, this can help you actually kind of do math related to your units. Or you just sit there and, okay, we're solving for time, and our time in the speed was years, so I know it has to be years. But you could also just do the math, because here you have kilometers over kilometers per year. Your kilometer divided by a kilometer cancels out, so then we have 1 over year, which is the same thing as just a year. 1 over a fraction, to get the fraction out of the bottom, you just hit the flip it. Okay? So, final answer is 17.5 years. The U is in there because this is one of the silliest things to lose points for, is not writing your units, and I will nail you every time. Okay? So if you do LASU, you'll be a lot less likely to forget the U. So that's the end of this. Literally, it's pretty easy. Just gotta do some practice so that you get LASU down. You get used to always writing your units. You get used to rearranging equations. You want to start out with easy stuff so that it ends up being easier for you. So see you in class tomorrow.